This video is designed to help you figure out how to answer the question how long it will take for a certain amount of money to grow to a certain a specified amount of increased money if you know what interest rate you are making. So the question right above at the top is saying that we're going to make $12,000, so we're going to want $12,000, and that's going to equal $5,000 of principal, and we're going to get 1 plus 0.06, 6%, written as a decimal. 1/4 of that is going to be our interest that's going to increase, that we're going to go up each quarter. And we're looking to find n, where n is the number of compounding periods, in this case number of quarters of years, that it will take for this to happen. Now, there are multiple ways to do this problem. One is to use logarithms to solve directly, but we're not going to worry about that right now because with a calculator it's fairly straightforward to guess and check, and we'd like to look at least how that process feels. The simplest way to do that is to take the 5,000 out of the equation by dividing each side by 5,000. What this does is give us 2.4 equals, and I'm going to calculate out the 0.06 over 4 and add it to 1. So it's going to give us 1.015 to some power. Now what we're going to do is we're going to guess some n's so that 1.015 raised to that power reaches or exceeds 2.4. What does the 2.4 mean? It means that we have 2.4 times as much money as we started with. In other words, this multiplier is simply going to be the thing that we multiply our principal by to get our new amount. So in essence, if we had picked 10,000 as the desired amount, we would have been saying, oh, let's double our money. Or if we had picked 15,000, we would have said, oh, let's triple our money. So the question could simply be, how long will it take for your money to grow to 2.4 times what you have to start with? Because it doesn't matter if you start with 5,000 and turn it into 12,000, or start with 10,000 and turn it into 24,000. It's still 2.4 times as big. So this multiplier is going to need to be 2.4 or bigger for that n to allow us to say, oh, that's enough time for it to grow and reach 12,000 or more, reach or exceed 12,000. So let's guess a few n's. If we guess n equals 20, we can simply do 1.015 to the 20th on our calculator, and we're going to find that that's approximately 1.34 and so on. So clearly it's too low. We need to go for more quarters than that. And by the way, 20 quarters would be 5 years because it's 4 times a year. So we need to go significantly longer than that. So let's guess 70. It's really useful to guess too big a number to know what your upper limit is. So if we do that, I've pre-calculated this one, and that winds up being about 2.83 something. So this is too big, but we now know that the number of years, the number of compounding periods, or quarters in this case, is somewhere between 20 and 70. If we guess 60, that's going to give us a pretty good feel. It's obviously we want to be a little closer to the 70 result than the 20 result, so let's guess 60. And if we do that, we're going to get about 2.4432. So obviously that's a pretty good guess. 60 is clearly enough to reach it. The question is 59 enough to reach it? If 59 is enough, is 58 enough to reach it? We're close enough now, we can probably just check that. So if we try 59, 1.015 to the 59th is approximately 2.407, so we're very close, but just enough above 2.4 to say, yes, that will reach it. What we should double check even though we suspect it's not going to work, is if n equaling 58 is going to reach 2.4. And it does not. It gives us about 2.37 something. So what that means is n equaling 59 is the right number. So that means there's 59 quarters. But if I ask you how long that will be, and I'm asking for an answer in years, you're going to need to say how many times does 4 go into 59, because you're going to need to divide that into quarters, turn that into years. So 4 goes into 59, 1, carry that, bring that down, 19, 4, that's going to give us 16, so that's a remainder of 3 quarters, which means our answer is 14 3/4 years, or we could also write it as 14 years and 9 months. I'll do one more problem of this type on the next page. Hopefully that will help you. So here's a second problem, which you may want to try yourself, and therefore pause this before you see my solution, but we'll work through it now. So if you're going to do this problem, so let's set this up. What this says is your multiplier is going to be equal to 3. What is the multiplier? It's whatever you're raising each month, which is 8%, 1/12 of 8%, raised to the nth power. So if we clean that up a little bit, we're going to get 1.0066 repeating raised to the nth power. So this is a little annoying because it doesn't give us a nice easy number that we can type in each time, but it's not that hard to type in 0.08, divide by 12, get an answer, add 1, get an answer by just hitting equals again, and then raising that to your guess. So if we start with a guess, let's guess nice and high. Let's guess n equals 200, and if we solve that, then 1.0066 repeating raised to the 200th gives us approximately 3.77, etc. So we know that's too big. We know that it's got to be less than 200. I'm going to guess 160, and I'm going to get n equaling 160. We then get 1.0066 repeating raised to the 160th power is approximately 2.89. So we know it's somewhere between those two. It's clearly closer to 160 than it is to 200. So let's guess, I don't know, 165. And so we'll try n equals 165. So that means 1.0066 repeating to the 165th power gives us 2.99, it turns out, 3 something, so just below it. So let's guess 166 and see if we get lucky. Looks like we've narrowed it down pretty quickly here. So 1.0066 repeating to the 166th turns out to be, yep, 3.013 and so on. So what that means is 166 months, because each compounding period is a month. If we want to find out how long that is in years, then we divide 12 into 166, and we get 1, that's 12, and that's going to give us 46, so that's going to give us 3, and 3 times 12 is 36, so that's a remainder of 10, so it's going to be 13 10/12 years. But of course, that's also known as 13 years and 10 months. I hope this has helped.